SARS-CoV-2 genome sequencing has presented a unique opportunity to track the evolution of the virus in near real time. Reconstructing a robust phylogeny of the existing virus variants is an intuitive approach. However, one of the main problems of this approach is scalability. Building phylogenetic tree will be harder as more genomes are added every day. Because of this roadblock, our goal was to come up with a rapid way to categorize the genomes that scales readily and leads to as little information loss as possible. We saw actually an opportunity to combine our allele identifying tool What'sInU with multi-locus sequence typing approach, which has been widely used in bacterial categorization and tracking the emergence of new lineages and associating specific clonal complexes and sequence types with certain diseases. Here we developed GNUVID, which is GNU-based virus identification tool that implements a whole genome multi-locus sequence typing approach, which is composed of all 10 open reading frames in the SARS-CoV-2 genome. It rapidly assigns an allele number to each gene nucleotide sequence in the virus genome, creating a sequence type which is codified as a sequence of allele numbers for each of the 10 genes in the viral genome. The sequence types are then linked into clearly defined clonal complexes that are consistent with phylogeny. And as you can see in the GNUVID workflow, we have used that approach on 32,719 SARS-CoV-2 genomes from GISAID. They are all high quality, high coverage genomes. We identified 17,615 sequence types, which were then clustered into 70 clonal complexes. Once a newly sequenced genome can be assigned, once a new genome is sequenced, we can assign a sequence type and clonal complex by matching to the compressed database. In figure number 1 here, we can see minimum spanning tree of the 17,615 sequence types, which shows 70 clonal complexes, and the bar chart shows that the percentage distribution of genomes from the different geographical regions. A status of the clonal complex can be one of 3, which is inactive, which wasn't seen for a month before, or quiet or black label here in this figure, which is 2 to 4 weeks before August 17 in this case, or red or active, which is actually seen 2 weeks before August 17, which was that database update. The active clonal complexes in this case was from 3 geographic regions, 2 mostly from Asia, 1 from Europe, and mostly 1 from Oceania. The analysis uncovered strong association of the sequence type and clonal complexes with certain geographical regions, but also dynamic local exchanges in sequence type and clonal complex prevalence. Another great utility of GNUVID is actually temporal plots of the circulating clonal complexes in certain geographical regions. We have applied that to 6 states in the US: Washington, California, New York, Wisconsin, Florida, and Massachusetts. And the plots show waves of expansion and replacement of SARS-CoV-2 clonal complexes in the 6 states. The number of mutative introductions and exportations were also predicted, and they are actually based on identical sequence type to be seen in another geographical region at least 10 days prior to the isolation date in that state. In Washington and California, 2 clear replacement events in which clonal complex 256 or 4 were replaced by clonal complex 258 and later replaced by another clonal complex, which is 300 and 498 in the 2 states. In New York, a different pattern was seen, where clonal complex 258 being persistently dominant across all time points. In Wisconsin and Florida and Massachusetts, 1 replacement event by clonal complex 258 happened. Also in the right panels here, we can see ratios reflecting circulating diversity and detection of new viruses in the 6 states, which decreased with the shelter-in-place restrictions and then rebounded with the subsequent easing of restrictions. Also, the proportion of introduced sequence type decreased over time and was increasingly dominated by introductions from other US states compared to overseas introduction early in the pandemic. Continuing ST-based analysis may help uncover new introductions, hotspots, or rapidly expanding clones and the impact of targeted interventions. Thank you.